data. Let me reduce the size of it. Just want to show you the flow, how people usually go with this. So they'll have the data. From the data, they'll say, okay, once I have the data, I'll clean the data. And once the data is being cleaned, they'll say, okay, do the EDA, which is exploratory data analysis. Then people will say, okay, I'll do the data transformation slash normalization so that the data can be easily fed to the machine learning algorithm. Then they will decide the ML model. And this is the whole flow I'm talking about. Decide the ML model, and then they will train the model, and then they will evaluate the model, and eventually they will deploy the model. Okay. In every step, for example, if I'm talking about data transformation, there are different kind of techniques that will help you to transform or encode the data. There are different machine learning algorithms to this specific task for each and every task. Okay, which algorithm you have tried, why you have tried that algorithm. While training the model, there are also different training techniques. Which have you used? If I made a project, all the whys should be clear. Why you are doing this in this way only, not the other way around. And on in the exact same thing, which kind of evaluation metrics you are using. If it's a classification based problem, are you using precision or recall or F1 score or accuracy? Which one are you using? Right? And why are you using it? And then it's not a single step process, it's an iterative process. After training and evaluation, you will go back and probably decide another model. And then eventually you need to deploy it. So in every step, there are a lot of moving parts that you need to work on, Okay. And the projects are not made on collab. Projects, if you want to make a deployable project, you make it on VS Code. You make it on coding editor. Okay. So there are a lot of things the people are missing. They are making just the project just for the sake of making it. They are not making deployable projects that can be deployed because companies are asking for people who can deploy the projects. It's not about just making collab notebooks, right? Collab notebook is something that everyone can make. But deployment is something where more than 95% of the people missing, more than 95% of freshers missing. So what you should be doing, your main task is to work on deployable projects, the project that can be deployed. Okay. So these are some of the mistakes that we have seen, which students are usually making. Okay. And at the meantime, if any one of you have any question during the process as well, do let me know. I'll be more than happy to answer queries. So make sure to add it in the chats. Now the thing is, what should be the ideal path? What you should be doing? For that purpose, I'm taking a project in my mind. Because eventually, if you have made a project that has decent complexity, you know every whys of it. Why you decided this model, what you have taken this data set, why you have taken that, why not another one. If you have all the whys cleared, you can easily defend that project. Rather than having 10 very mediocre level project or very basic level project, make sure to have one decent level project where you can defend each and every part. Okay. And now I'm going to talk about one of that kind of a project. Okay. And rather than directly going for a project, so this is, let me write, this is a very important part, like project versus product. What is the main difference between project versus product? Any guess? What is the main difference between a project versus a product? Anyone? This is where the whole mindset will change. The way you are proceeding ahead with the project, the whole mindset will change with just the single term, right? What people are usually making, people are making projects. They are not making products. Project means, for example, I want to make a stock price prediction algorithm that can predict the stock price. Seems like a very simple problem, right? So what you can do, you can take any data set, take any machine learning model, and then train it on the model and check the model accuracy, evaluation, and see if the model is working. You might be thinking the model is working. That's it, right? This is the project mindset. Product mindset is my algorithm working? If my algorithm is working, how can I make it better? Okay. Is my algorithm working on Nifty data set, Nifty 50 data sets, or Nifty 100, or Nifty Bank, or 250, or which particular data set? Is it working on do we have any algorithm that is working great on Nifty 50 but not good on Nifty 100? Okay. Can I deploy this whole project to the end user on my website so that user can come to my website and they can see what my algorithm is predicting and what my algorithm has predicted over the past? And can people purchase my algorithms or purchase the UI or basically do a subscription on my website so that they can have the access to all the different AI models that can give prediction to these models? This is the product side mindset. Whenever you are making a project, have a mindset of building a product. This is one of the very important component. If you want to make a project based on product mindset, one project is enough, because this one project will take a month. It will easily take a month for you to make. Okay. But to make a project, you can easily make a project in 2 hours. Okay. So this is a very important mindset you need to change. You need to shift your mindset from project making things to product making things. This will make a whole lot of difference. Okay, now let's talk about an ideal project that you should be making. Okay, this is something we are also going to making in the course. Okay, S- and this is the project where we are also personally working on. So if you have worked on Geeks for Geeks, if you went to Geeks for Geeks, so in Geeks for Geeks we have a search bar where user can search for any query. For example, the user is writing for gate, so user will get different articles on gate. Okay, logic gate, not gate, NAND gate, database management system gate, CAC. Yes, whenever user is searching for anything, query being written. Okay, for example, GAN, GAN versus auxiliary GAN. So here you can see how based on the query I'm writing, how I'm most relevant result. Okay, there are different techniques in machine learning, traditional string-based search as well, that will give you the answer in that. Okay, but the thing will you get these articles? So AI-based search engine. Clear? You're going to build this AI search engine. But this is one of the component. Or on top of that, for example, if you have opened this article, what should be the next article you should be reading? If the user is reading this article, what should be the next article the person might be reading? Right? Like where I can add the segment here, like these are also the articles that you should be going ahead with. How we can add that component into it? And on top of that, if we can have a chat bot, right? Not a very traditional chatbot where I'm making an LLM call. For example, I'm asking ChatGPT, what is GAN? It will give you a generic answer, what is GAN? But if I want the answer from my knowledge base, which is a RAG based system, if you know what is RAG, so like you know what I'm talking about. But RAG is basically a fancy kind of an architecture where rather than asking LLM a question and getting the answer, LLM will ask from my knowledge base, my set of article where I have like 1,60,000, 1,85,000 around articles, and give you an answer based on those articles. Okay, this is what I'm talking about. So if you want to make this level of project where you have a project where you have three different components working, you have a search engine, you have recommendation system of articles, you have a chatbot that can give answer based on the knowledge base. This is the level of complexity I'm talking about. This project will take easily 15 days, right? And here in this project, you can have traditional ML techniques, you can have deep learning techniques, you can have generative AI algorithms working on that as well, right? So this is an end-to-end project that we are going to make. Okay, now let me tell you the flow that you should be knowing while making this kind of project. This is a decent level of project, and to teach you this project, because we are also coming up uh with a course where we'll teach this project. So just for your understanding, just to show you how exactly in the organization this data is stored and how we are doing the API calls and everything, we have simulated a data set on MongoDB. Okay, and here you can see for every title, like we have simulated, not simulated, but we have the exact articles. Like we have the article title, the name, the author, likes, tags. So whenever you are making an API call, you will get the article as a response. So it's not like a traditional data set JSON file that you have saved on your system. This is a database to database communication from the server we are going to make. Okay, so this is the level of complexity I'm talking about. I'm not talking about some dummy project. Okay. Now let me tell you about some of the architectures, some of the architecture about this whole project. Okay. So here, as I've told you, we have mainly three components. We have recommendation system where it will recommend the articles. This is the part one of it. The second part is rather than just recommending the articles, it's more on article search. This is second part. And the third part is a chatbot, AI chatbot, or more of a RAG chatbot. Okay, so these are the three things that we are going to make, three different components, which are huge components on its own that we are going to make. Okay, and let's talk a little bit about the architecture. Okay, so whenever a user is asking, so there will be a user query that will have. So whenever user will write a query, that query will be searched on my existing DB. Okay, right now I'm just making it very generic, but along with the time I'll add more complexity into this. Okay, so whenever user is writing a query, I have a DB of articles. I have database of articles, and inside that database of articles, I'll search this query. Like a user want to search for the article on rack, right? Or probably on GANs. So I'll get the answer of that. Okay, so this is the traditional technique that I'm trying. Okay, so where I'll have a user query, user will search for something inside my database. I'll search for the articles and get the response. This is a traditional technique, right? But right now, this is not the technique that we are using, right? Because it's not only about searching the article based on the title, right? For example, here I am writing here GAN and I'm getting all the results where the title is GAN. But let's suppose if I'm talking about noise in GANs. Okay, so here I am not having direct article on noise and GAN, but inside each article, I might have some parts where the article has written noise. Okay, so I cannot directly go for title based search. I also need to go for the content inside the article. And from that, I need to search the content, right? And just to make a calculation, imagine if I have 1,80,000 articles. Every article has around, let's suppose, like 2,000 word. So I have basically 360 million words. For every user query, I'm not going to search for 360 million words, right? So to overcome that problem, we have a technique called as RAG. This is the most advanced technique right now we are using. Okay, so in the RAG technique, what we usually are doing, will have a vector database. So rather than, so here we have articles, exact articles, but those articles, I'm saving it in a vector database. We call it as vector DB. So inside vector DB, we are storing, like here we usually have all the articles. For example, we have article number 1, we have article number 2, all the content. They are not only articles, they are something that looks something like this. We have the title of the article last updated. We have the exact content as well. If I like hover over it, I might get all the details of it as well. But let me copy it to show you what's the detail I'm talking about. So this is the detail I'm talking about. This is the content I'm talking about. So here you can see this is the whole content of the article. Okay. And this is huge, as you can see. Clear? So this is what I'm talking about. So we have a whole article here. So eventually the best thing we can do is I'll take all these articles, convert them into vector DB. So they are vector embeddings. And let me show you that as well. Directly, I cannot show you these vector embeddings because inside that we have the vector. So this is the vector DB where we are storing all the embedding. We'll discuss a lot about it. This just to show you a demonstration. Like this is going to be a an actual project where the data is saved in the databases. We are doing a lot of server communication and getting the results. So now what will happen whenever user is asking the query will be sent to a vector DB, and from the vector DB you will get the answer. Okay, and I will create a vector DB for all the articles, so that through this vector DB, if user is asking from the vector DB, I'll get the answer. Either it is the recommendation system of recommending what should be the next article, and the same thing will also will helping you for AI search. The exact same thing will also help you to make a RAG based chatbot, and that too based on these things. Right now, let me tell you about some of the main components that we are going to discuss, or what are the main key highlights of this project which you should be learning. Okay, so first thing you need to learn is VS Code, how to write the code professionally in VS Code. Okay, we'll discuss about virtual environments. Okay, or it's not about we are going to learn, it's about what you should know as a data scientist. Okay, you need to know VS Code, you need to know how to work on virtual environments. You also need to know how to work on Git, code versioning tool, right? Git. You also need to know about GitHub, which is again a versioning tool. Okay. Apart from that, you need to know about libraries. You need to know about how whenever we are working on large libraries, you need to know about object-oriented programming. Oops. The concept of oops. Because whenever I'm making bigger project where I have like 10, 20 files, I have different components working together, I need to know oops, because there are multiple files that are communicating with each other. I cannot have a very big file where I have like hundreds of functions working. So I need to make this code modular. So oops is very important here. And whenever you are having multiple files communicating with each other, so folder structure. How will you define the folder structure if you have hundreds of files working together, right? After that, you need to work on APIs. If your code is communicating with the databases, so you need to know how to communicate with the APIs, right? And for APIs, you need to know request library, or if the data is coming from, let's suppose, servers, or you need to scrape the data from the website, so you need to use request library. You need to know about APIs. You need to know about databases, not only traditional databases like just SQL base, but also NoSQL base. So you need to know about MySQL or PostgreSQL. You need to know about NoSQL databases like MongoDB, because some of the data will be stored in MongoDB, like the article that I've just shown you. Apart from that, you also need to know about vector databases. Vector databases like we have Pinecone, we have OpenSearch, we have ChromaDB. They are some of the vector DBs that you need to know about, right? And these are the things where most of the people are missing. They just know one thing, that's Colab. On Google Colab, they'll do everything. And when I'm talking about Git and GitHub, they will just download the Google Colab, upload it on GitHub. That's it. But there are a lot of moving parts that a data and scientist should know. Okay, and versioning vector DBs, and whenever you are talking about vector DBs, like I'm not talking about the traditional ML algorithms, deep learning algorithm, the architecture of it, versioning of it, because that's something that most of the people already know. They are doing the same thing on Collab as well. I'm talking about the how you can become top 1% of the data scientists, or want to get if you want to get top 1% of data science jobs, what exactly are the things that you should be targeting? Okay, so I'm not adding those components. Apart from that, obviously, if you are working on a RAG-based system, you need to know about what are databases. You need to know about how Llama Index works, which is again a library, Llama Index, or we also have a library called as LangChain. You need to know about them. When talking about APIs, you need to know about these LLMs, what are LLMs, how to choose an LLM, like which LLM will work, how to use chunking techniques. If there are people who already know some of the terminologies, they will understand what I'm talking about. I'm not digging deeper into each and every component. I'm just telling you what are the things that you should be knowing. Okay. LLM calls, prompting, prompt designing is an important field. Like which prompt is working, which prompt is not. Prompt versioning is also designing slash versioning. Okay, chunking techniques, vector DB, we have similarity metrics, like to check if your LLM is working correctly or not. So there are a lot of things that you need to know. And most important, once you have made everything, how will you deploy this project? You need to know about Dockers, because eventually you need to make this whole project as a Docker container so that you can host it to anywhere, right? How will you log these matrices? How will you do the logging? Like if a model is working correctly or not, and what are the token consumption, what is the latency, what is the throughput? All these things are very important. Loading, or basically load testing, okay, or API testing. And API testing usually will use Postman for that. Okay. And in the exact same way, when I'm talking about Dockers, you also need to know about when exactly you want to host an application, on which cloud source you want to host it. Like you need to know about Google Cloud Run. Not specific to Google Cloud Run, but any of the deployment like GCP slash AWS, right? So there are a lot of things that students are missing. And these are the things that they should know, because making a project is very easy. Making a product, deploying it is difficult. If you know this thing, you will become top 1% of it. And seriously speaking, I have taken a lot of interviews. Most of the people are just in this level. They are just making Google Colab. That's it. They are not writing codes on VS Code. They are not having the mindset of to deploy the things on in the production. Okay. And this is exactly what we are going to do. Okay. Now, let me talk about what I'm talking about when I'm saying what we are going to do. So, as most of you might be aware, that we are coming up with a data science project program. Okay, this winters, and this is the course page of that. Okay, and inside this course page, you can understand, like along with me, we are also having some another like expert mentors who's going to take this program, and inside this program, we are going to make this exact project that I've just shown you. A search engine which where we'll use different semantic search techniques. We are going to use RAG based technique, which is generative AI chatbot techniques, recommendation system, and we are going to complete this project end to end. What exactly does it take to complete a project from starting from scratch, 0 to 1, from zero to the production, to checking how exactly all the things are missing components are working, right? How the model on like once deployed is working, how to monitor if your model is working correctly or not. Okay. And there are also tools that I have missed during the discussion, but SQL Alchemy is a very important thing that you should be knowing. PyTest to write test cases, right? We also have Pydantic to write codes in, like to do the data modeling basically. Okay. Fast API to write the backend, because eventually if you want to deploy a project, you need to build the endpoints. So Fast API will help you in that. Transformers, Pinecone is a library for vector DB, right? Spacey for text cleaning. We have OpenAI, Gemini. These are the LLM libraries that I'm going to call. So I'm going to implement a lot of things, combine all the things together, and eventually deploy it on Google Cloud Run by using CI/CD pipeline. There is a lot that we are going to discuss in this program. So this is a 15 days program that we are coming up with. Okay, and these are the first two components that I have discussed. Like first one is what are the major mistakes the students are doing. This is the problem that they are facing. They are having the project mindset, not the product mindset. And these are some of the things that students should know. And they are also not all the things, but they are the things that I don't think so. If you, like majority of you might have a project mindset, so these are the things that might be new for them. Okay, or they might heard about these terms, they have not worked on them. Okay, so these are the things that they must know, and they are also not all of them. In the description you will get the link of, means basically if you go to the page, you will get a lot of details about this thing as well, the course as well. Okay, now talking about the program, talking about the project in a bit detail. Okay, this is the basic presentation. So we are going to build data ingestion pipeline where we'll take the raw CSV files, or basically the data from the article, store it in the MongoDB that I've just shown you. Okay, and once that is done, we'll do the text cleaning, text search, and we'll do the similarity search kind of techniques to get which article will work best. Then gradually we will increase the thing, like from machine learning techniques to deep learning techniques to vector DB techniques, where we will work on vector database, which I was talking about, which is a totally new technique to work on vector DBs, to basically work on search engine algorithms. Okay, or searching algorithm, content searching algorithm. And whenever the article is huge, so we need to chunk the article into multiple factors as well, so that the if inside an article, inside a sub region, we have the thing we are getting, so we can also do that. Then we'll discuss about rack thing, we'll build a rack chatbot as well, and also recommendation engine, like what they should be doing next. At the end, we'll do a hybrid search of combining all the things together and see how everything is working. We'll build the back end of that as well and deploy the same thing on Google Cloud Run. Okay, so this is going to a 0 to 1 project where we'll start from machine learning, traditional machine learning techniques, and go to the latest techniques. Okay, so this is about the whole project that we are going to make. And as I've told you, like the future of AI is bright, because most of the innovation right now being done are on AI. Okay. There might be some new things coming up, for example, quantum computing along with AI that can revolutionize some new thing. But right now, if I'm talking about every field along with AI is revolutionizing it. For example, we have designers right now as well, but we have designers that are using AI. We have editors who are using AI. We have content writers who are using AI. We have mentors who are using AI. So the future is every field along with AI. So that's why the future of this field is also huge. And these are some of the tools that you should be knowing in that field. There's the traditional career impact that a fresher can make somewhere around 6 to 10 lakhs, and a senior data scientist can get easy up to 25 plus lakhs in this field of data scientist. And what this field is for, this field is for mathematicians who are great at mathematics, not mathematicians, but who's good at maths, who are good at coding, who have a keen interest in problem solving and writing codes. Okay, and talking about the program, I've just shown you, like we have this program where we'll discuss about the hands-on capstone project that we have just discussed. We are going to make this project 0 to 1 in 15 days. You will get a training certificate. You will get the Kaggle context throughout the process as well. You will get the recorded content, which is additional recorded content in very detail on machine learning, on data analytics, on data science, on generative AI, on deep learning, on computer vision. So there is, for every uh, topic that we have talked about, we have a detailed 10 plus hour of course on each topic. Okay, you'll also get 24/7 doubt support and interview preparation, and along with that one-on-one career guidance with the mentors. Okay, and this is the course that is coming up on different offline centers: Bangalore, Pune, Noida, Hyderabad, Kolkata, and you can go to the link as well. I'm going to share the link with you in the chats. And now let's talk about the very important announcement, right? And the announcement is, here is the coupon code. Okay, this is the coupon code year end 40, where if you go for this particular coupon code, you will get easy 40% discount on the courses that we want to go ahead. Like, this is specific to data science project, so this is the coupon code you can apply on any of the courses. Okay, so you can copy this code. Like, I'm taking the screen just for like 10 more seconds so that you can take a screenshot if you want to, or even if you want, I can share the same code in the chats. Okay, so this is year end 40, year end 40. So that's the coupon code. So you guys can go for this specific coupon code, go to this course, enroll in now, and go to the coupon code, and you can get 40% off, because now we are coming with the winter sale. Okay, now that's basically it. That's basically Let's basically summarize everything that we have done. So to summarize, we have discussed about the main three components. First component is, what are the main mistakes the people are making as a fresher in the field of data science. Then we have discussed about what a person should be doing, where I have given you a demo of the project. This is not the project, like, this is not something like only we can teach you. If you have enough time, you can teach it by yourself as well. I have given you a whole roadmap. Like, this is what we are going to make. Okay, if you want a what I would say, mentor guided course or mentor guided roadmap along with the hand holding, so definitely this is the course that you should be doing. But apart from that, if you are confident enough that you can do it by yourself, feel free to go ahead with it. Okay, so these are the three things that we have discussed so far. If you still have any doubt, I'm open for for like taking the question for 1 more minute. Otherwise, we can wrap the things up. I hope the session makes sense to you. I hope I'm able to communicate my ideas clearly to you. And if you still have any question, not right now, probably in the future, I'm also sharing one more resource with you, which is my LinkedIn, so that in the future as well, if you have any question, you guys can connect with me over there. Okay. So thank you so much everyone for joining in. I hope uh, to see you soon. Take care everyone. Thank you so much.